Hello, everybody. How you doing today? This is Dr. Bachnak coming at you. The disorganized man that I am. I think I got this week all settled for you. First, I'm going to go over the blackboard for you, and then we're going to get into climate change. We're going to get another section done, another like 20 or 30 slides, and then I'm going to do another one for you tomorrow because I don't want you to have to watch an hour and a half video. I'm going to try to keep it in some snippets for you, so I hope you don't mind me breaking it up like this because this is an important chapter. But first, let me go over the um, outline here for you for this class. So this is week 5. We're on global climate change. You guys just handed in your current event, and then you have chapter 14 due on this Sunday by midnight, right? And then we'll go on to chapter 6. And please note, I changed this. I skipped a chapter. So I put this biodiversity and conservation biology in here, chapter 8, for week 6. If you're already doing week 7, that's okay, or the economics, because that's the next one. All right, but this is an important one. I don't know why I skipped it. I was wondering why I was missing some stuff. I was thinking about things that I usually talk about, and they weren't there. And I realized I skipped chapter 8. So I put chapter 8 back in. So next week, instead of the 11th, your economics one being due, it's going to be this one. All right, due on the 11th, and then you have a current event and not that podcast because that podcast goes along with week 7's stuff, which is now economics, policy, and sustainable development. All right. So I want you to read chapter 5 and do the crazy town. All right. But note here that next week we are going to be having our 2 weeks, 3 weeks, I guess. We're going to have a test. So on Wednesday, when you post this Crazy Town podcast, I am also have a test prepared for you, and I am going to post that on the 14th, and you'll have a week to take it. So next week, on the 8th week, all right, you can have an exam. You won't see it pop up yet. I haven't made it available for you, all right? But it's just multiple choice, 35 multiple choice, 5 true false, and 5 like short answers. Not huge essay questions. Just what's the definition of first and second law of thermodynamics, all right? What's the definition of sustainable development? I just want simple couple sentences answers here. This is not essay questions, okay? And it's worth 100 points. So on Wednesday, the 14th, I will post it, and you'll have until next Wednesday to take it. So you see here, you do not have a current event or a Wednesday assignment. The Wednesday assignment is to have the test completed by then. It will be up for a week, but it has to be completed by the 21st. All right. And then in week 9, we start getting into soil agriculture and food of the future, how we're going to start solving some of these problems. All right. So we'll finish up climate change and then the biodiversity stuff, and that will get some of the basic science stuff out of the way, and then we'll talk about how we as a society are going to fix some of these ails and problems. Okay. So having said that, I hope that is clear. If anybody has any questions about that or concerns, let me know. I think all my dates are all right here on both classes because I got 2 of these classes going on. Please forgive me. This is the first time I've done this all online, and for 12 years I taught this in class, so I'm learning. I'm learning as I go, but I know some stuff, so at least I'm catching this. And we will get everything ready to go. So what is this? This is human population. Where is my climate change? Oh no, here it is. Okay, here is climate change PowerPoint. Okay. So let's talk a little bit about climate change. So when we studied climate change, the reason we know the climate is changing is because we have looked in the past, right? We looked in the past and seen what was happened. We've actually, looked at old ancient records. I told you about El Nino and El Nina and how that was actually once talked about by the ancient Peruvian Indians, right? They had that 7-year cycle that they wrote about all the time. And we use these things called proxy indicators as well, which are a type of indirect measurements that serves as the substitutes of the direct measurements. All right, so these are called proxy indicators. And what proxy indicator, what scientists do is they drill into these ice caps or ice sheets in the glaciers to analyze these tiny little bubbles, right? So, when you have an ice cube, there's actually a couple bubbles in that ice cube. And that bubble is full of what? Air, right? So they take a little core sample out of here, dating back, the ice is just layered up, just like the soil's layered up when the archaeologist is doing things to figure out what time period they're at. The ice is the same way. And we cut off a little sliver, melt down that ice, and that atmosphere that was trapped in there is now analyzed, and we can figure out how much carbon was in the atmosphere, how much nitrogen oxide was in the atmosphere, how much of this oxygen, how much of this and that and that. All right. And then we can put that in our database. All right. And when the scientists are thinking about doing their models, they go back and they do what's called back testing. They see if that model actually represents what they found in the back. And if it's good, then they say, hey, maybe this is good for the future. And then they progressed into the future and they got that 95% confidence level. And that's how we get these things. All right. So it's not based on just a bunch of, assumptions. It's based on old data, proxy data that they have collected. And another one also, it's like tree rings, right? So we know when the tree rings are bigger that there's more water that week, right, or that year, okay? Pack rat middens in arid regions. So we look at all the garbage left over from different areas, the mittens, all right? And isotope concentrates and samples of coral reefs also give us the same kind of information. So there's a lot of different indicators that we have used to test these models with from past data, right? So we're just not observing what's going on today. We're actually looking in the past as well. And we have a good time frame, about 1860, I think, was our first real climate model or whatever, and we started calculating all the data, all the real data. So we were actually taking raw measurements of the atmosphere and ocean levels and temperature all around the world. So we were starting to work together on this climate thing way back in 1860. So we have data going all the way from then to here today. And if we put that together, holy guacamole, that's even more convincing. All right, that is raw data that reading the temperatures of today. Man's actually recorded these, and then we use that proxy data. Put all that together, we got one heck of a climate model, and you could see in that last video I showed you, those climate scientists were spot on almost all of the time. All right. So studying climate change, here we see the difference of the J curve showing up. All right, and you can see that this methane one is just really going a little crazy. All right, which I'm kind of scared about. But we usually concentrate as a society on the CO2 out there in the atmosphere. Okay, and you can see how the temperature has actually changed, is corresponded with these. And you see how these two are, these are greenhouse gases. And you see these are way up here, but the temperature isn't really up there now. And it is smart to ask, why is that? Why isn't that temperature, this black line as high as this blue and this red line, if it is corresponding? And if you really pay a little bit close attention to how these lines are lining up, the temperature is actually a lagging indicator from the greenhouse gases. And what I mean by that is, when you put a pot of water on the stove and turn on that heat, does it start boiling right away? No, not that I know of, right? It takes some time for things to warm up. And we're at that point right now where it's starting to warm up, right? We got to get those little CO2 balloons that are in the atmosphere full of latent heat. And it takes a while, just like the pot of water takes a while to boil. So does the temperature change. Okay. So direct measurements tell us about the present. So in 1958, Charles Nealing, the great Nealing curve, the hockey stick, began analyzing hourly air samples, monitoring it from the station in Hawaii. And concentrations have increased from 315 parts per million, right, in 1958 to over 400. Actually, it's 411 today. Right? That is what the latest reading was at the site was 411. And that is, folks, that's a lot. All right. Humanity grew up. We always known about, three, now 280 to maybe 320 parts per million. Um, we've never seen 411 parts per million yet, and we don't know exactly what's going to happen to the air turbulence and stuff that we talked about last time. Um, and that's why 320. You ever hear of three? I don't know if you guys ever heard of the society 350.org. All right, and 350.org is named because they say that's really the tipping point when we really start getting in trouble with the climate. Once that parts per million CO2 concentrates gets over 350, and we're at 411, so we're way over it. We got to start bringing that down, and we want that's part of the Paris Accord. It's not, the Paris Accord was meant just to stabilize the carbon emissions to carbon zero, so we stay at that 411, and then we're going to try to attack bringing down the carbon emissions to that 320. But first, we got to stop adding carbon to the atmosphere, and that's what Paris Accord was all about. Climate models are programs that have combined with known about the atmospheric circulation, ocean circulation, feedback cycles, and all that stuff into a computer program so it can help predict what will happen. All right, and the efficiencies of these models is tested by entering past data, climate data. Like I said, it's called back testing. All right, and then we see if that was, looks okay, if that data kind of supports what we saw in the past data, and then we do one to the present. All right, current models are they're not perfect. All right, they don't claim to be perfect. They're only 97%, 99% confidence levels on there, but that's pretty darn good. All right, and then there's always that measurement of error as well. So they don't say they have the number exact. All right, so the Earth's climate system is complex, and there's many feedback loops, and some things aren't really known. So the climate scientists aren't perfect, and they readily admit that they do have some problems with their models, but they try to fix them. All right, when they do that, so they admit it and they do try to fix them, which is very impressive, in my humble opinion. So climate change has already had numerous impacts on physical properties of this planet. So we can see a lot of different things that have happened in organisms and ecosystems and on human well-being. So, we talked about the flooding in Miami that happens on sunny days, all right? Multi-year droughts in Texas and California. Texas and California are still trying to recover from the last multi-year droughts. And it was bad. Those droughts were bad. It really hurt their ecosystem and their economy. And we've had some unprecedented heat waves and cold snaps here in Pittsburgh. We have all those. We have that cold snap that happens, an Arctic blast. Yeah, I remember I grew up. We never had those Arctic blasts. Now we do. All right, and heat waves in Pakistan and India are just ravaging those countries during the summertime. And in Australia, so we got this all. It's happening all over the world, and this costs money every time this kind of stuff happens. It hurts the economy, and I don't want a bad economy. I want a good economy. So what we have done, with this scientific evidence, we've, worked together. So, in 1986, we did the Sustainable Development Goals, and all of a sudden we started working together as a world, and we formed what's called the International Governmental Panel on Climate Change, which is it's known as the IPCC, right? And it was established in 1988 by the United Nations to review and summarize all available data, climate studies for policies and general public. So the IPCC report is not written in stone, folks. It doesn't tell anybody what to do. All right, what it is a scientific report that we put together, society put together with all the best, thinkers around the world from all these different nations. Okay, so we got the best data out there, and these guys and gals are not, trying to put a fast one over you. They're just trying to tell you like it is. Right? And in 2013-14 report, the IPCC released its fifth assessment, summarizing the trends in surface temperature, precipitation patterns, and snow and ice, and all these other factors. And believe you me, it did not look good, right? They say the average surface temperature, both land and ocean, have risen by already 1.1 degree Celsius in the past 100 years. So we've already had 1.1 degrees Celsius in average temperatures, okay? In the United States, the temperatures in most areas have risen by more than a full degree Fahrenheit in just the past 2 decades. And, we have these things, and, I'm a gardener and a farmer. I have a farm, so I know a lot about gardening. There's these things called average frost dates. And the Farmer's Almanac will come out with those every year for you. So what that tells you as a gardener or a farmer is when you can plant crops and when you have when the crops are done. So, and it talks about the first frost. So you don't want to put your tomatoes out until the first frost is over. Okay, and then you want to harvest your tomatoes before the first frost starts because the tomatoes don't like frost. They die off real bad and they kill the taste of the tomatoes. And what has happened is that the first frost is getting later, it is getting earlier and earlier. It's not happening, actually. It's getting earlier and earlier. So instead of being in May, like it's usually in May, right? Or the last frost is usually in May, the last frost is now starting at the end of April here in Pittsburgh. Okay, and then the first frost used to be in the beginning of October, now isn't happening until November. So we actually have an extra 2 months just about of planting season here in Pittsburgh. All right, and that's due to the change in temperature because it's getting warmer. All right, now that's amazing. Okay, I remember when that new planting chart came out on the news, and everybody's like, "Don't start planting banana trees. It's not that hot." I'm like, "Ah, come on, tell the truth of why that's happening." All right, so every year every 10 years, the Farmer's Almanac will do this, and the last 10 of the 10 years, they've had to change the frost dates. It's gotten expanded because it's gotten warmer. So future changes in temperatures are predicted to vary from region to region. Okay, this is a non-linear kind of expansion in temperatures, like Al Gore was talking about. All right, because the polar ice caps are going to get a lot hotter, a lot faster than the equator, and this is basically just due to the positive feedback loop that sits upon here. All right, because all this is a bunch of ice, right? And when it gets warmer, the snow is going to melt, and then that reflective ability of the snow is not going to be there, and then the warmth is going to be, sequestered in the oceans, making it warmer. All right, so that's why the top area is a little bit, it will get warmer a lot faster. Okay, because of the albedo effect is no longer there. All this cold ice cap is going to be gone, and all that's going to be there are dark landmass and water that is going to soak up more heat, hence making it hotter, making it a positive feedback loop. But what also could happen too is the methane, like we talked a little bit about this before. The tundra area up here, all right, holds a lot of bacteria that love to eat some organic waste. All right, and there's a lot of organic waste just sitting there frozen, waiting to thaw out. And when it thaws out, they're going to start doing their little thing. And when they start doing their little thing, they're going to release methane into the atmosphere, and that's a very potent greenhouse gas, more potent than CO2. So that can start even a bigger feedback loop. Okay, that might not necessarily make this any hotter. All right, because it's already going to be hot down there. It's just going to be adding more greenhouse gas and keeping it there. So this will eventually slow down this increase. Okay, because we'll get that to that equilibrium point when there's no snow and the temperature will adjust. Okay. A warmer atmosphere speeds also evaporation, and we hold more water vapor, and the precipitation has increased worldwide 2% over the past century. So we've added 2% more water vapor into the atmosphere due to our activities. All right, our global warming. And we have 2% more water vapor in the atmosphere. That means 2% more rain is coming down. So those 100-year floods are now 50-year floods, and those 50-year floods are now 100-year floods, and those 100-year floods are now 1,000-year floods. Okay, and we have been seeing this happen time and time again over the last 15, 20 years, that the floods and the water damage is getting worse and worse. And it's also important to note that some regions will receive above average rain and snow, while others will receive less. All right, so it's expected that the desert areas too, and you see these dry areas, are actually going to get less and less water. But Al Gore was talking about, I'm talking about, scientists talk about all these jet streams that move some of this water and around and heat around it. This is all kind of up in the air, because what if that Gulf Stream stops? There's not going to be any. They already have some of, this is the Middle East here, but I bet you Europe's not going to have any wind blowing any moisture over to the European side there. Okay, if those trade winds just shut down from that cycle. Okay, the frequencies of extreme weather events, such as droughts and hurricanes and stuff, has doubled in the United States since the 1970s. Okay, so we've had doubling occurrence of all the droughts, floods, hurricanes, and tornadoes. Now, please note, tornadoes, the science, let me go back. How did I just do that? Science has not confirmed any tornadoes to climate change. Okay, we still don't know exactly how the tornadoes are formed, but they have increased. Okay, the hurricanes, yes, hurricanes need to hit the United States, but we have plenty of hurricanes out there that don't. But we've definitely seen the impact of droughts and floods, and the hurricanes, when they get here, are just much bigger. All right, you just do a Google search. I think it's Wilma was the last one that hit Florida, but you should compare Hurricane Andrew compared to Hurricane Wilma. And the size difference between those two hurricanes is phenomenal. One is like just about to hit Hurricane Andrew, like hit Miami or something, and it was small. It was just about as big as that city, all right. And Hurricane Wilma was like as big as all the state of Florida. It's amazing to see those two on a graph side by side, all right. In 2012, saw a March heat wave, severe droughts, and Superstorm Sandy. In 2017, we saw hurricanes like Harvey and Irma. So I'm sure you guys probably keep up with the hurricane news and the catastrophes, and they're getting worse and worse and worse. We talked about the forest fires too, right? I know last semester when I started this class, Australia was on fire. This semester when I start this class, all of California is on fire. We almost had to, move everybody out of Portland because it was so dangerous. So there's definitely something going on. And insurers have noticed this. They have had a record doubling of losses in Europe and even higher rates across the rest of the world. So insurers, are starting to really feel the pinch. Okay, and some of them are just not insuring anymore houses for these hurricanes. Or if you do have one and you get insurance, you're paying a pretty penny for that insurance. Okay. So it's just not profitable for the insurance companies to take on that risk, because that risk is very real and getting stronger and stronger. And they're going to go bankrupt. Right? A 2012 study revealed a potential explanation for the increased extreme weather. All right, so like we said, we are not saying that the weather doesn't stop. It's just the increase. It has been exacerbated by the warming. Right? And a lot of people don't like to hear that, but it is true. The warming has been greatest in the Arctic, weakening and intensifying the North Hemisphere polar jet stream. So we got this polar jet stream right here that used to, be nice and constant in society. I mean, it really is what kept the difference. Boy, that was weird. It kept a difference between, Canada's cold Arctic blast coming down here and hitting Pittsburgh as much. Okay, but since this is weakening, we got some warmer water up here in the Pacific. Sometimes it's pushing this jet stream all the way up here, and the bottom part is coming all the way down here into Florida. We're losing all oranges, and we're getting 20-degree weather here in Pittsburgh, Pennsylvania. Negative 20-degree weather here in Pittsburgh, Pennsylvania. And then that scientists are saying that is due to this weakening of the jet stream is due to that. And like Al Gore said, all this is really up in the air. We still don't know what is going to happen with all these currents, the ocean current and the jet streams and wind currents that we have. Okay, because we can't get that notification out of air bubbles. All right, we have to really be there to see what happens to the jet streams. Okay, so this is one of the the scientists are clear that they are not 100% certain about this stuff. Okay, and there are some different predictions out there, but all those predictions are saying that things are going to be different. Okay, and a jet stream is just a high altitude current. All right, that wanders, and there's a bunch of jet streams around us. Okay, and you can see what has happened. The cold air has been pulling it down here. You see the big, huge dropping down real far, and then persistent warm weather here. And the reverse can happen too. This can go all the way up here, and we have cold weather here. So we've seen some very big swings in the past, I say 10 years, of this jet stream that we've never seen before. And it's causing all these weather patterns to be held in place for long periods of time. So we have extended heat waves and we have extended cold waves that used to not happen. We used to have the constant weather. Many tropical mountains out there, mountaintop glaciers have disappeared, and a few that were remaining are shrinking. 1 out of 6 people worldwide live in regions that depend on mountain water as a source. So I think this is Jackson Glacier, 1911. You can see it right here. All right, and then it has totally disappeared in this picture, just about. Okay, but you got to remember this one. This sentence is very, very important. 1 out of 6 people worldwide live in regions that depend on mountain melt water as a source of fresh water. Okay, California is one of them. All right, California gets most of their water, almost all their water, from the snowpack over the wintertime in the Rocky Mountains. And I remember, can't remember who, I think the governor was Jerry Brown was the governor at the time. And he gave this little press conference. He walked up and he was sitting there in this nice little Rocky Mountain meadow, He grabbed this stick and he put the stick down on the ground and said, "This stick right here is used to measure the snow." And there was no snow on the ground. He goes, "We measure the snow because we can calculate then how much water we will have during the summertime because the snow provides us with our drinking water." And lo and behold, there's no snow for them to measure. Okay, so the drinking water from that area was going to be 0. All right, I'm sure he took the stick somewhere else and got some snow somewhere. Okay, but that's how we do it. We measure the snow, and then we figure out how much water. That's how California does it. But there's other countries too that depend on this melting glacier snow. All right, India, Pakistan, and China all share the snow melt from the great, I don't know what that mountain range is called, but it's like in Tibet. Mount Everest. Okay, I can't remember what the range is called, but that's where they get their water. And there's this little tiny area up there that they're all disputed because that's where like the biggest glacier is, and that's where most of the water melts in goes. But that mountain range feeds all 3 of those countries, and all 3 of those countries do not really get along too well together, right? And I believe that this is just putting more strain on their relationship because even here in the United States, we'll talk about this a little bit during the water section, we have states that have been disputing each other. So Florida, Georgia, and Mississippi have been in courts for about 15 years fighting over water. All right, and just think about China, Japan, and Pakistan fighting over water. All right, and they don't have courts to go to. They got to work it out, between themselves and try to be nice about it. Okay. So the entire West Arctic ice shelf is potentially on its way to an unstoppable path. So this is the Arctic, and this was one we're really concerned about the most. Okay, is the Arctic ice shelf. The Antarctic, yes, it is succumbing, but we don't really have too much activity up there. All right, and it's not doesn't have as much land mass and problems as the Arctic, but it is definitely as the Antarctic is not having as much problems as the Arctic. Okay. Um, but if this was going to actually, get rid of all this, it will cause about 3 meters rise in sea levels. Right, and the ice sheet in Greenland is also melting, and the Arctic sea ice is also thinning. So the Antarctic is not going to is potentially on its way to unstoppable collapse. So it is slowly but surely melting, but the Arctic is really is concerning many of the scientists at the more rapid of a pace. Right, and you can see here how this is the Antarctic ice sheet and or the Arctic ice sheet, and you can see how it's disappearing over the years. All right, so it was 10, 10 billion kilometers, right? And now it is only about 6. It was over that, about 11. Wow, amazing. Okay, so the melting ice has far-reaching effects. So the snow and the ice melt. It gives us that less reflective surface, and that's what starts that positive feedback loop. All right, that we talked about. And this reduces Earth's capacity to reflect the light, creating a positive feedback loop. So that's one of the reasons why the upper region is going to get warmer and warmer, because it's no longer going to have that snow and ice to reflect it. It's going to start absorbing the temperature, and it's going to become a heat sink instead of a heat repellent reflector. Okay? The loss of Arctic ice has led to the opening of the new shipping lanes too, and this is a big geopolitical problem. I can't say problem, but a discussion. So everybody's trying to, now that we have some shipping lanes, believe it or not, so that Russia does not have too much access to the oceans. All right, their real access is up in the Arctic Sea. And now that this ice has come up, they are able to have some better shipping lanes. And believe you me, they want to go for it. Okay, and there are a lot of other countries jockeying for positions to claim regions in the Arctic for the oil and mineral extraction. So everybody's out there trying to say, hey, if we can actually get some ships out there, we can put an oil rig there and get some of that oil that we know is up there. All right. So there's a lot of geopolitical concerns about the opening of that ice. Okay, and we'll talk a little bit more about that later when we talk about the fossil fuel industry. Okay. Arctic warming is thawing the permafrost, and this is what really is my scariest thing. Okay, once that permafrost becomes alive, that starts the anaerobic bacteria starting to decompose all that stuff that's underneath there, and they are a greenhouse gas emission and methane. That's what they exhale. All right, and it is going to be a total positive feedback loop. I don't know how we're going to stop it if it does start, and we're starting to see some signs of that. All right, there's these Google Russia has holes in Siberia or something. Okay, and what they have found is that these guys will be taking around the reindeer or whatever, will walk over and they'll see this big crater. All right, and they're like, "What the heck happened here?" Okay, and they have no idea. And scientists are trying to figure it out. They still don't know for certain. But what they think these craters, these little pock marks that are showing up in Siberia, what they think they are is from global warming, okay? Because it's not they don't have meteors coming down there and making these. All right, these little pock marks, these little craters. They don't have, military is not practicing anywhere around there. But what they have deduced is that this methane, okay, since the Siberia is part of that Arctic, right, and the permafrost is defrosting, these anaerobic bacteria are starting to do their thing and releasing methane, and it builds up underneath the ground and eventually blows up, creating those potholes in the ground. Okay, can you imagine that? You're walking around with your reindeer, and all of a sudden whoa, that's crazy. Okay, but no one's ever seen one go off. All right, but I guess it could happen, and that is just their assumption. The scientists still cannot prove that that's what these pop marks are from, but nothing else fits. All right, like I said, there's no evidence of a comet or a meteor or anything like that happening. So worldwide average of sea levels have risen 24 centimeters already in the past 135 years. And this leads to more beach erosion, coastal flooding, saltwater intrusion, great impact on local sea rises and sea levels, which are called storm surges. Okay, so you can see on this little thing, the gray area on here, it was the statistical uncertainty of way back when, right? But you can see here how this gray area starts getting smaller. So we have a little bit more certainty because we have actual data. So this is the back testing kind of stuff, all right? But we can see here that we are almost spot on. And this red one is where we are estimating it should be at the very end, okay? But you can see it has actually, since we started tracking it with the satellite data, it is definitely tight together with the scientific models that we have, okay? And it's also important to note that though the sea level is rising 24.1 centimeters in the past 135 years, also the land is shrinking. It's getting smaller, folks. All right, getting lower. All right, I think I talked about this last class where we had Norfolk, Virginia, which is our biggest naval base. And what they're noticing is all their docks and their ships and buildings on that place is starting to shrink. It's starting to decrease elevation, and not just due to these coastal flooding and beach erosion and saltwater intrusion, is moving up into the land a little bit further and then taking out all those little air pockets of the sand that Norfolk is actually built upon. All right, it's not like Florida where it has some hard shells built on a more of a solid base, right? Of old seashells. Basically, that's what Florida is built on. Norfolk is built more of a sandy loam. Okay, and it's starting to decrease. Right? And I was in the Navy back in early '90s during Desert Storm, the first Gulf War, and we were just starting to. I noticed the change when I was in the Navy, how we started to change some of the things, especially when we painted. We used to paint like crazy, and we didn't care about the environment and all that stuff. And all of a sudden, we started noticing these things. I started noticing how the regulations were changing because it was that point in time when the Navy started getting serious about Norfolk is sinking, folks. Right? And they've gotten even worse. I mean, they've gotten done even more. So we have to move our docks. We got to do something. Okay. And the Navy is definitely into it about trying to save that port because it is our biggest military port for America. Very important place, but it's sinking. All right. So you can see right here, Norfolk land is subsiding and flooding threatens neighborhoods and the world's largest naval base. Okay. New York City's the same. I remember Al Gore, when he did his little speeches, for climate change, everybody was laughing at him. He said that the 9/11 memorial, if we have a big flood or big hurricane, the 9/11 memorial will be flooded. That's just the way it is. And everybody laughed at him and said, that ain't gonna happen. But lo and behold, Hurricane Sandy, guess what happened? 9/11 memorial flooded. Okay, so there's definitely a lot of stuff. Boston, San Francisco, Texas. I mean, this is the oil capital of the world right here. We got more refineries down here than you know what to do with Galveston, Texas. Okay, New Orleans, and Tampa, Florida. So it's all these coastal cities here in the United States are in big trouble, and these are some of our major places of economic stability. Right, and it makes sense that we have it along the coast because who doesn't like to live around the coast? So people from small islands too, like the country of Maldives, most of which is less than 1 meter above sea level, may become climate refuge as the sea level rise. So the whole island is out of here, and all these people are going to have to leave. Okay, and that's kind of like the environmental justice that we talked about in chapter 1. Who is going to pay for that? The people of the Maldives um, caused this? Is this their problem? But now the whole nation is no longer going to be gone because everybody else was, well, I'm sure they do some carbon emissions, but it's going to be gone. Okay. But we've already done this too for the United States. We've had to move a Inuit Indian community off one of their islands up there in Alaska because that island just wasn't safe for them to live on anymore. So we had to move them to their homeland, to the continent. All right, they were living on this island for I don't know how many thousands and thousands and thousands of years doing nothing. Just going out and doing their kayaking thing and stuff like that, having their living their ways. And they had to be transferred off the island because it was just too dangerous for them to live there anymore. So multi-major storms have demonstrated that the potential impact that storm surge can have on a metropolitan area in the United States. So Superstorm Sandy caused about $65 billion in damage, killed 160 people, thousands and thousands of people homeless. Okay, and that was a pretty darn big storm. We never really had that many people die in a hurricane in a long, long, long time because we got the money to have some good infrastructure, but unfortunately, we weren't really prepared for the infrastructure up in New York City isn't made to take on the big hurricane winds that Super Sandy provided for us. All right, they're not like Florida. You never think about a hurricane and those big winds getting to New York City. So their infrastructure wasn't as built up as much as Florida's is, because Florida gets hit by hurricanes and strong winds. And we lost 160 people during that storm, and that wasn't good. That's our good number. All right. In 2017, we got Hurricane Harvey and Irma that devastated Houston, the coastal cities in Miami, to Jacksonville, to Charleston. So we've spent billions and billions and billions and billions and billions of dollars, hundreds of billions of dollars, cleaning up after these hurricanes. And luckily, this season hasn't been too bad. Though we are on, the second level of naming, like we're using Greek letters or something like that now for the hurricanes. But they're out there, and we've been lucky that we haven't been hit too often. We only had about 3 or 4 actually hit the United States this year. All right, but we're still in hurricane season. That still can happen, and there's still some out there that are forming. We just don't talk about them because they don't. They just stay out to sea. But here you can see Superstorm Sandy was caused by the global warming. Was not caused by global warming, but it was facilitated and strengthened by it. All right, so global warming isn't making hurricanes. Okay, hurricanes happen naturally; they'll always be around as long as this Earth has a little bit of heat to it. Okay, but they definitely make them stronger because hurricanes are driven by the heat of the ocean. They take that energy, that heat energy out, and put it into the sky. And the warmer the ocean, the more energy they can draw from it. So it's definitely being exacerbated. Okay, and you can see here some Sandy, right? Shoreline of homes toppled with most of the storm surge. We are not used to this storm surge here in New York at all. I mean, with Florida and stuff, we kind of expect it, okay? But we never thought a big hurricane like this could actually get up to. I mean, it has before. It's a 1 in 100 year event, but this was, it's happened. And also, the storm surge goes up into Miami, up into these inways, right? Which is actually flooding the um, 9/11 memorial. Okay, because New York City is built basically right on the coast and a whole bunch of islands. Okay, we have no trees or anything like that, but it's there, right there, and you can see how the sea level rise has gone up from 1990, 1900 to 2020. Currently, more than half the U.S. population lives on coastal countries in coastal counties. not countries, but counties. And about 3.7 million Americans live within 1 vertical meter of high tide line. 3.7 million, 1 vertical meter of high tide line. There's this one guy, I can't remember his name. He was talking about, it's great. You can just sell your house if you don't want to live there in Florida. I'm like, well, you ain't going to be able to sell your house when it has 1 meter of water in it at all times because it's right there during high tide now. I mean, it's just unbelievable. So all these people here are in trouble, right? Their houses or, the skyscrapers are all going to be underwater, right, during high tide. South Florida is judged to be the most at risk, though, with 2.4 million people just in South Florida. 1.3 million homes and 1.8 million acres are vulnerable to being wiped off this map, or not wiped off this map, but put underneath water. All right, and then we'll Florida Keys for you. So get down there if you're gonna try to enjoy them, because I don't think they're gonna be around too much longer. But that's just my humble opinion and the scientific data that I follow. Another big problem with global warming is just with all the extra carbon in the atmosphere is the acidifying of the oceans. All right, and this was it didn't get anywhere, but it was one of my favorite techniques because carbon dioxide is not a pollutant. All right, it doesn't do us damage. I can still breathe. Right. I'm carbon life form. You're a carbon-based life form. Almost everything in this earth is a carbon-based life form. Carbon dioxide is a good thing, right? It allows us to have life, right? So what the industry was saying is saying that the EPA, the Environmental Protection Agency, cannot regulate carbon emissions because it's not a pollutant. It doesn't do us harm, and a pollutant is defined as something that changes, does you physically harm or changes something chemically or physically. And carbon dioxide does not do that. Okay, but what we have found is that the added carbon dioxide is being put into the carbon sink of the ocean, and changing the acidic level of the ocean. All right, and a phenomenon known as ocean acidification. So, climate denier, or climate activists tried their best to say, hey, the EPA can regulate CO2 because it is changing the ocean chemically. All right, it's changing, it's making it more acidic. And when it makes it more acidic, that kills off the plants, and the animals then are no longer there. All right, everything needs that fine pH level that we talked about, right? About 7.5 pH, right? Neutral, not too acidic, not too little acidic, right? Right there in that neutral part, okay? And all the coral and all the sea life has the same thing that we have. They are at that 7.5% acidic level too, right there in the middle. And it's getting more and more acidic. And as that happens, the carbonate ions become less available for calcium carbonate dissolves, jeopardizing marine life that produce shells. So all your shrimp and your seashells and your oysters, all that stuff will start disintegrating because of that acid because the water is more acidic, and they won't be able to live. Okay, unless they have a mutation somewhere along the line that allows them to grow tougher shells or something. Okay, and we can't count on that. So globally, ocean chemistry has already increased by 1 unit pH, 0.1 unit pH, which is about 26% increase in the acidic level. All right, so we can definitely test it, but we still don't have the EPA allowed to regulate carbon dioxide. All right, well, it was a good try. Hopefully, we'll get it done with the next administration. Okay, but the acidic oceans are hurting the coral reefs. They face 2 additional risks from global warming. First, the acidicness of the oceans, but also the warmer water is contributing to a phenomenon called coral bleaching. All right. So coral has an automatic little lever in it. When it starts getting the water starts getting a certain temperature, they start turning white. All right. It's like a defense mechanism, but unfortunately, that defense mechanism isn't turning off, and they are dying. So they're bleaching out. Most of the coral reefs in Australia right now are just about dead. All right, about 83% of it, or something like that. It's crazy. Do a current event on the coral reefs of Australia, and it is just saddening. All right, and I don't know how we can, decrease the temperature of the oceans fast enough to stop this reversal. All right, to stop them from bleaching out. I'm not too sure what we're going to do. All right. All we're trying to do is try to find some strains that can actually take a warmer temperature and trying to populate the coral like that. But we'll see what happens. But there's a lot of good scientists trying to work on it. But society needs to do its job too and stop putting out more CO2 than the Earth can absorb at one time. Okay. And also the stronger storms are physically damaging the reef. So now we have stronger hurricanes. There's going to be stronger currents underneath that could possibly break this coral off real easy. Okay, so we got the acid hurting it, the warmer water's hurting it, and the stronger physical storms are hurting it. So many biological phenomena that rely on temperature have been modified by global warming. Like I said, we have, in Pittsburgh, we already have 2 extra months of planting. We can plant an extra month early, and we can have our tomatoes a month later, right? Due to the farmer's almanac noticing the temperatures have changed. But we don't think about 1 degree temperature really affecting the ecosystem, right? But you think about your body. If you go up to 99 degrees, you're not feeling too good. You go up to 90, 100 degrees, you're really sick. Okay, so 1 degree temperature can affect our body, all right? But it can also affect the ecosystem. So in the spring, plants are leafing a little bit earlier, and insects are hatching a little bit earlier. So when the birds are migrating, because they have like an internal clock, right? And they're not really there, they don't know what the temperature is up here in Pittsburgh, all right? But with the insects have more of a temperature gauge. So when the temperature starts getting to a certain time, that's when the eggs will start hatching. And the birds come up here and they're a little bit late to get all these insects. So they might not have enough food to rear their young because the insects hatched a little bit too early, right? And even the plants says it's leafing, but even plants need a certain germination temperature, right? So like when I plant my lettuce, I like to do it real early in the spring because the temperature of the soil is really good, but it hates heat. All right, so you try to put it in like way before early April, so you can harvest it before the summertime comes, before June. All right, or else it's going to turn really bitter. And what's been happening to me lately is that I have to pick up my lettuce a lot earlier because it's getting a lot hotter, and the plant doesn't survive in that heat. It only takes that little a couple months. Okay. The good news is I get a longer time during the winter time, so I've been planting most of my lettuce in August, so I can harvest it later in September and October. And it's lasting a lot longer because guess what? We're not having that frost. Okay, which is nice for me, but bad for the animals, right? Because this insect and bird relationship is very, very important, right? Many animals are expanding their ranges towards cooler areas too and higher elevations. So I already talked about the pine forests in North Carolina that are getting decimated by the pine borer beetle. And this is a beetle that comes up every summertime because it kind of runs out of room down south, and it's nice and warm for the summer during the summertime. So it flies up to North Carolina and starts eating those trees. But North Carolina used to get cold for 11 days straight for a long, long time. All right, I mean for 11 days because we're really I don't know if it's 11 days, something like that. It's like 11 days of below zero weather will kill off this bug, right? And then it'll be all disappear, and then they have to travel. A new population will have to travel up during the summertime and start eating the trees. And then it will get cold for about 11 days and kill off the population, and then a new population will come on. and they would do their things. But what's happening is now we're not getting that cold spell that we used to have. And those beetles are hanging out longer the whole year, eating away on those trees, decimating that pine forest. Okay. And hence the population's growing. And then when it gets warmer, guess what's happening? The pine beetles are going up even further north, right? And lucky here in Pittsburgh, we still got those frozen days where it stops them from staying all year round and starting a family, right? But maybe someday we won't have that coldness, and then all of our trees here in Pittsburgh will be gone too. Okay, so just these little tiny changes, this 1 degree temperature change in the environment pulls and tugs on so many little things that we don't even think about. And it's very important that we start discussing them and seeing their impact of what it is. Okay. Moderate warming also may increase agricultural output, right, in some temperature areas, but increased droughts will diminish in yields for many other areas, right? I love it when people say, oh, we'll just start growing wheat up in Canada. And yeah, I guess we can grow wheat up in Canada when it gets, the year 2100 because it's nice and warm up there. But what about the American farmer? Right? We're supposed to be the breadbasket of the world. Now Canada, I guess, is going to be the breadbasket of the world. Right? And if you're planting weed up in Canada, that methane has already started a positive feedback loop that is, it's a disaster. Right? The one thing I don't like about the IPCC model is that they keep on I'm not the only one that says this, but they keep on saying that the economy is just going to be great. We're still going to have enough food and all this stuff, cars and everything for everybody. Our economy is just going to keep on chugging along, right? But meanwhile, we're going to have all these droughts taking away all our food, right? And floods wiping out all our food source. And I don't know how the workers are going to work without any food, right? Well, that's neither here nor there. All right. Increased CO2 may also spur timber growth, right? But warmer temperatures also increase the rates of invasive species, fires, and disease breakout. All right. So we might get faster growing trees, but when we're burning them down with these forest fires that we see in California this year, it can't keep up. There's no way. Okay. So we got to do something about all this stuff and start addressing this a little bit more seriously. Okay, and they also talk about disease outbreaks too, what's inside the ecosystem because we don't know what is actually out there. For instance, this ancient, just like those amoebas live in the Arctic, in the soil and just waiting to wake up. This ancient, 1,000-year-old reindeer or something like that came up in Siberia and thawed out. Okay, got through natural evolution, whatever, thawed out, and there was this old strain of anthrax in it and wiped out this huge herd. All right, and they found out that it was some ancient strain of anthrax that we'd never seen. And anthrax been around, all right, but it was all done. They traced it back to this one old deer that they found that was kind of preserved and thawed out, and that anthrax came back to life. So there might be a lot of disease sitting frozen in those ice caps in the Arctic that we do not know about. Okay. So warmer climates expose us to many potential health problems too. All right. So we've got more frequent heat waves, respiratory ailments due to photochemical smog, right? Expansion of tropical disease such as malaria in temperate latitudes. I don't know if you guys remember the Zika outbreak that we still are dealing with, all right, and malaria. So all those, like I said, those mosquitoes are now moving up north because of the warmer weather and surviving. And they're carrying the malaria and the Zika virus all the way up to here. Disease and sanitation problems from flooding and sewage treatment plants. Okay, when we have these big floods, very rarely do people talk about all the sewage that gets overflowed, or even some of the oil refineries and coal pits and farm agricultural waste and all this stuff. Those things are in little ponds. And when those ponds, all that toxic soup is sitting there in the ponds, and they get over flooded and go over the bounds of the pond, it gets into the environment, and it is just we ain't cleaning it up. All right, there's a lot of problems with that as well. And also the injury and drowning from the worsened storms. Like I said, 160 people dying in a hurricane in America it's almost unprecedented. That hasn't happened since like the 1920s. All right, I mean it happens in a third world country, but not here in America. But New York's not built to take on hurricane force winds and storm surges like that. Okay. So economically, climate change is expected to widen the gap between the rich and the poor, as people with less wealth rely more heavily on resources likely to be disputed. All right, we're going to have a lot more um, conflict due to climate change. The social cost, all right, of carbon is estimated to be anywhere between $10 and $350 per ton. So there's something in economics that we'll talk about next during the economics chapter. It's called negative externalities. All right, and the negative externality is just something that it's a cost that you pass on to somebody else. Okay, so they say that the fossil fuel companies, since they are burning the carbon, are selling the carbon, and that's kind of like free. We don't get charged for it. All right, we buy the oil, but that's it. We don't get charged for the climate change. So when we put it out there, we're using the commons, we're using the atmosphere for free. All right, but we found out by putting that carbon in the atmosphere, it's warming up the society, causing these bigger hurricanes and droughts and all this stuff. So there's actually a cost to us burning, an added cost that we're not putting in the price of the gasoline. Okay? And what they say is that cost is anywhere between $10 and $350 a ton. All right, and that's a big spread. All right, and what society has been trying to do since 1990 is come up with a number we can agree on. Right? I don't even agree on these numbers. I think it should be about $500 a ton. All right, that's what I think. But that's just me. But I think we got to put something on carbon. All right, a price of carbon. We'll talk a little bit more about that in the economic section. All right, because we've got to pay for the true cost of our products. All right, not socialism, nothing like that. It's called paying the true cost of the products. And I understand businesses, they want you want to make money. The best way to make money is to internalize the profits and externalize the cost. And this carbon is an externalization of the social cost of carbon. Okay, and we got to start putting that into our price of our gasoline. As much as I don't like paying more, I got to pay the true cost. There was also a thing called the Stern Review on Economics and Climate Change, which is, I think, from Europe, a bunch of Europeans, right? And they concluded that climate change would cost the world about 5 to 20% of its gross domestic product by the year 2020. So climate change, trying to keep everybody, dealing with all the damage and stuff, is going to cost us between 5 to 20% of our GDP. We'll be fixing things up more than we will getting better. All right. But if we just took about 1% of our gross domestic product starting now, it could help avoid many of these costs in the future. All right. So what they're saying is, instead of going out and buying all this stuff, take 1% of the stuff that we buy. All right. And put that money towards fighting climate change. Whether that's building solar panels or putting up some new seawalls in an old country, in a country that can't afford it or something. We got to start spending some money to mitigate these problems. If we don't spend this 1% of all we spend, we're going to have 5 to 20% going down the drain, trying just to survive. Okay, and I don't think 1% is asking too much, right? I I do a lot. All right, I got solar panels, I got windmills, I drive a electric, partial electric car. It also has a gasoline in it too. So I've reduced my carbon footprint and I've reduced my GDP, my spending a lot because I have switched to environmental friendly ways. So this is my point. If anybody out there doesn't want to sacrifice their 1%, come see me. I can't do the whole class, all right? But if you really can't, get rid of your 1% and give it to fighting climate change, tell me. I might be able to give you a couple of my extra credits, all right? So you can still live happy. But 1% of what we spend every year, I think, can easily go into the piggy bank to help fight climate change. All we got to do is do it, folks. All right? That's all we have to do is do it. We just got to step up and start doing this. I am hashtag Green New Deal. I'm all about it. All right. And it's not some crazy socialist takeover. All right. It's common business sense. If you want to have an economy, if you want to have people spending money and having a fun time and enjoying life, we're going to have to do something about climate change. That's just the way it is. Okay. Because climate change can contribute to humanitarian, geopolitical, and national security problems. The United States military says our number one threat to our geopolitical and national security is climate change. All right? Because they say the Syrians, I don't know if you guys keep up with geopolitical stuff, but there's a civil war that was still going on in Syria. But they say that it was all part of climate change. Because the farmers in Syria went through a huge drought, and they're still going through that drought. All right, and it's worse. It was worse than the ones we have in Texas and California. So they had to leave their land, and they moved to the city, and there was no jobs for them. All right, and they started bumping elbows and getting all crazy, and some guy let himself on fire. It's called the Arab Spring. He literally torched himself because he was in protest. All right, and next thing you know, Syria is blowing up, and the Middle East is blowing up, and it is crazy. And there's strife inside those countries. It wasn't big wars, all right? It wasn't crazy wars. It was inside their countries because the people were at unrest, all right? Because they had nowhere to go, no food to eat, because the land was all dry. So now this is very important to address, all right? That these geopolitical concerns are very, very real, and they're happening in our lifetime. You might have to dig a little bit deep to realize the connection between climate change, and there's some other things too, right? There's some religious things and some other things that happen inside these conflicts. All right, it's a dynamic. These are dynamic problems, but climate change definitely does draw together, right? Because if I'm hungry and cannot eat, I am going to be mean, right? It's just the way it is, right? And I'm also going to have oil and gas flows are going to be disrupted, right? And people in some affected regions may be refugees and turn to terrorism, right? If I don't have something to eat, no one likes terrorism, all right? But like I said, if we can, way back when we talked about Maslow's hierarchy needs, and I'll talk about this again in the economics part too. I just think governments has a purpose, and some of the purpose is to make sure that people can at least meet their needs of the basic needs of food, safety, water, and education, stuff like that. Okay, these small needs. I'm not telling the government doesn't have to tell you what car to drive or what to be when you grow up or whatever, but they need to help you so you can be comfortable in your own skin and not worry about things so you can become a better human being. But when people are not able to feed and clothe themselves and get enough water, they get mad, all right? And they blame others, all right? And sometimes some of this terrorism stuff is actions towards others who got bombed first, all right? But you can understand when you get hungry, I bet you get mad and you get a little bit less irritable, okay? So scientists agree today that global warming is a result of increased greenhouse gases. And we're actually going to stop at this one, I think. Okay, I think this is where I wanted to. Yeah, about 49, and then we'll have about 20 more for the next one. Okay, yeah, that looks good. So we're going to stop here on this one, and I'm going to show you next class. I'm going to show you my one of my favorite um, global warming videos, the political system. All right. So be prepared for that. A little cliffhanger for Friday's presentation, and I'll post that up tomorrow for you because I have to get ready for dinner and I have gymnastics tonight. Well, my daughter has gymnastics tonight, so I can't do it tonight, but I'll do it tomorrow morning. We'll finish up climate change. So once again, you guys have any questions? Give me drop me an email, and we will be talking to you soon. Okay. Thanks.